Sample problem 3, and hopefully your physics class has these little hoppers. They're like a little tiny thing about the size of your thumb, made out of some kind of rubber plasticky thing that you press it down and then it unpresses itself and springs up into the air. And you measure the height, and then what you can do is find the hopper's initial velocity, which is kind of neat. So our steps, let's draw a sketch. So here's the ground, x0 is equal to 0. We want to find the velocity that the hopper leaves with once you let it go. What do you know at the top? Its very maximum height, it has a final velocity of 0. We've done that. It stops momentarily as it's going up because what? Then it has to come down. And we know the height because you had some kind of meter stick or some kind of measuring device. Once again, the hopper is moving through the air, so the acceleration will be negative 9.8 meters per second squared. Even when the hopper is going up, the acceleration is still in the down direction, right? Gravity is always pointing down, whether you're going up or down. Let's list our given variables, any appropriate constants, and the variables we're looking for. This was measured. This is you start on the ground, so that's 0. This is our appropriate constant, the acceleration due to gravity. At the top, they didn't tell us what the velocity is, but we know when you shoot an object in the air, right before it starts coming down, its velocity will be 0, and we're trying to find the initial velocity, v0. Select an appropriate equation to use. The correct equation will be v squared, v0 squared plus 2a x minus x0, the third kinematics. Why is that? Well, if you look at what we have up here, we have v, we have x, we have x0, we have a. The only thing we're missing is v0. Notice there's no mention of time in this problem, so whenever you don't see time, immediately think of the third kinematics. Start with the equation that we've selected. That would be this, third kinematics. Both x0 and v equal 0, so cancel them out. Okay, so v is going to be 0. Make sure you leave the 0 on the left side of the equation. And what are we canceling? We're canceling out x0. So we have 0 is v0 squared plus 2ax. What do we need now? We would like to get v0 all by itself. So we will add a negative 2ax to both sides, which means on the left side we'll have negative 2ax because it was added to 0. And on the right side, 2ax plus a negative 2ax, or 2ax minus 2ax is 0. So it goes out. We just have v0 squared. Swap them around. So v0 squared is minus 2ax. But we don't want v0 squared. We want v0. So take the square root of both sides. And we finally wind up with v0 is the square root of minus 2ax. And that might bother you, right? You see a negative sign in a square root? We can't do that, at least not at this level of math. But let's wait for the next slide. Here's our solved equation. And if you're worried about the negative 2, which is fair, well, here's negative 2. But look, a is negative 9.8 meters per second squared because it's in the down direction. Then we plug in the height that the hopper went to, calculate it out, and we round to 3 digits and get 5.24 meters per second.